Hello everyone, I am Rama. In this lecture, I am going to show some problems using the formulas, Newton's forward and backward interpolation formulas. In the previous lecture, I have shown how to derive Newton's forward formula. Let us take that formula here. Y is equals to y naught plus p delta y naught plus p into p minus 1 by 2 factorial delta square y naught plus p into p minus 1 into p minus 2 by 3 factorial delta cubed y naught plus and so on. We should construct this formula up to the last difference in our table according to the given data, where P is evaluated using x minus x naught by h. X is where it is a point where y is to be determined. X naught is either this is near to x or else always you can take x naught as the beginning value of the table, starting value of the table. H is difference between every two successive x values. Doing small modifications to this formula, we can easily write our Newton's backward formula. For this, I am not going to give the proof again. To get Newton's backward formula from forward, we need to make changes that x naught equals to xn and y naught is equals to yn, delta is equals to del. Instead of minus, we need to take plus, so that Newton's backward formula can be written as y is equals to yn plus p del yn plus p into p plus 1 by 2 factorial del square yn plus p into p plus 1 into p plus 2 by 3 factorial del cube yn plus and so on, where p can be evaluated using the formula x minus x naught, x minus xn by h. P is given by x minus xn by h. When we need to use these two formulas. Newton's forward formula is useful to interpolate y, to find y at some x which is near the beginning of the table. And Newton's backward formula is useful to interpolate or to find y at any x which is near the ending of the table. Let us see some examples now. Let us see problem. Using Newton's forward interpolation formula and the given table values of x and y equal to f of x, obtain the value of f of x at x equal to 1.4. So clearly mentioned to use Newton's forward interpolation formula. So for any problem, first point is forming the difference table. And second step is to find the value of p. Third step is taking the formula. Fourth step is evaluation by using all the values taken from the difference table and from given data. So let us write the difference table first. Taking x and y values vertically. Now forming the difference table, taking the differences of y. So first forward differences 0.69 minus 0.21 successive minus preceding whatever the values are. We should always follow the pattern successive minus preceding values of y. The same is for the differences also. 0.69 minus 0.21, it is 0.48. 1.25 minus 0.69, 0.56. 1.89 minus 1.25, 0.64. 2.61 minus, minus 1.89, 0.72. Again taking the differences, 0.56 minus 0.48, 0.08. 0.64 minus 0.56, it is 0.08. 0.72 minus 0.64, it is 0.08. We can observe that in the second difference column, all the values are same. So, higher differences are obtained as 0. Since these two differences are zeros, we can consider our formula up to second order difference. Now, we need to find this p. The first step forming difference table is over. Now we will find p value. P is obtained for Newton's forward formula as x minus x naught by h. X is the value of x where y is to be determined. We are asked to find y equal to f of x at x equal to 1.4. Hence, we use x as 1.4 minus x naught. X naught, I have already told you, either the value is the starting value of the table or else it is near to x. In this problem, I am choosing x naught as 1.3 since this is near to 1.4 by h is the difference between every two successive x values. We can see here the difference between the first two successive values is 0.2. For the next two successive values 1.3, 1.5, difference is 0.2. And for next two successive values, the difference is 0.2. Again for next two successive x values, 0.2. So that will be our h. So we are using h equal to 0.2 here, which is nothing but 0.1 by 0.2. 0.1 by 0.2, nothing but 1 by 2. Now we need to write our formula. So we are writing by Newton's forward formula, yp is nothing but y at p 1 by 2, nothing but y of x means y of 1.4 is equals to y naught plus p delta y naught plus p minus 1 by 2 factorial delta square y naught. Y naught is the value of y corresponding to x naught. X naught is chosen as 1.3, hence the corresponding y is our y naught. Since we require delta y naught delta square y naught for forward differences, from y naught we need to consider a slanting line downwards. Then in the first differences column we get delta y naught. In the second differences column we will get delta square y naught, and the next one is delta cube y naught. No need to take it as the value is 0. So we are just substituting all the values. Y naught 0.69, delta y naught 0.56, delta square y naught 0.08. In this formula we are going to get the value as we got the value as 0.96. The value is 0.96. If I take x naught as 1.1, then the corresponding y naught will be 0.21. Hence, we need to take slanting line downwards from this y naught. Then there are 4 values on the slanting line. In the first difference column, we write delta y naught. In the second difference column, we write delta square y naught. In the third difference column, delta cube y naught. Fourth difference column, delta power 4 y naught. Even though we are getting non-zero values up to second order differences only. By taking these values also, we can evaluate y of 1.4. That means f of x at x equal to 1.4. In such a case, we may not be getting the same value as 0.96. There will be some error in the value. Let us see one more example. For x equal to 0, 1, 2, 3, 4, f of x values are given as 1, 14, 15, 12, 6. Then find the interpolating polynomial that fits the data. Whenever we are asked to find interpolating polynomial, whatever the starting point of the table we have, that should be taken as x naught and y naught. I already told you for any problem, the first point is we need to form a difference table. So we are just taking the values of given x and y values vertically and then forming the difference table. So you understood it very clearly, so I'm not going to touch it again. So from x values, we can clearly observe that the difference between every two successive x values is 1. Hence, h is equals to 1. And we are choosing starting values of the table as x naught, y naught. From y naught, we need to take differences by drawing a line, slanting line downwards from y naught. Then on the line, in the first difference column, we will get delta y naught. The second difference column, we get delta square y naught. The third difference column, we get delta cube y naught. And the last difference column, fourth difference column, we get delta power 4 y naught. As we have the values up to the fourth difference, we need to take our Newton's forward formula up to fourth difference. Before going to use the formula, let us calculate p-value. As h is 1, x naught is 0. As we are asked to get a polynomial, that means y equal to f of x in the variable x, we keep x as it is in p. So p is equals to x minus x naught by h, nothing but x minus 0 by 1. This is equals to x. From the table, we have already taken values. Now using this in the forward difference formula. This is our forward difference formula. In this we are using all the differences taken from the table and y naught and p equal to x. Then we are getting y, p nothing but y of x is equals to 1 plus x into delta y naught is 13. 13 plus x into x minus 1 by 2 factorial is nothing but 2 into delta square y naught is minus 12 plus x into x minus 1 into x minus 2 by 3 factorial is 6 into delta cube y naught is 1 plus x into x minus 1 into x minus 2 into x minus 3 by 4 factorial is nothing but 24 into delta power 4 y naught is 21. We need to simplify this polynomial. By simplifying this, we have got 1 by 24 into 21 x power 4 minus 122 x cube plus 75 x square plus 338x plus 24. This is our p of x. This is our approximate function p of x. That means y values are being approximated by the polynomial function p of x, and this satisfies the condition that this is passing through all the data points, nothing but f of xi, sorry, p of xi is equals to yn. So for verification purpose, we can give x values from the table. For each x, we must be getting the corresponding y. That will be, the condition will be satisfied by the polynomial what we have got here. Let us see one more example. The problem is the population of a town in the decimal census was given below. Estimate the population for the year 1925. It is not mentioned very clearly which formula is to be used for this problem. We are given year and population in the year. Year can be taken as x, population in thousands can be taken as y. Our first step is to form difference table. So here you can see the difference table is over. Now let us see our question. We need y at x equal to 1925. Now, we need to see its location. 1925, it lies between 1921 and 1931. That means 1925 is very near to the last data point, which is near to x, which is at the end of the table. Hence, we have to use Newton's backward formula. Newton's forward will not work. So that the last data point can be taken as not x naught, y naught. We should take them as xn and a corresponding y as yn. For Newton's backward formula, we require backward differences. To take the backward differences from yn, we need to draw a slanting line upwards. We can see it very clearly. Now, x is representing here. In 1925, we require the population. That means y. So x is 1925 here, and h is equals to 10. By observing x values are every two successive x values are divided by 10. Hence h is equals to 10, and xn equal to 1931. Corresponding y, nothing but yn, that is 101. So our second step is to find a p value. P is given by x minus xn by h. X is 1925, xn is 1931 by h is 10. By simplifying this, we are getting minus 0.1. In the difference table, we have up to fourth difference. So we need to consider our Newton's backward formula up to fourth difference. By Newton's backward formula, y of x, that is y using p value, is obtained as yn plus p del yn plus p into 2 plus 1 by 2 factorial del square yn. We should consider this formula up to del power 4 yn. Now using all the values from the table and p value, we can simplify yp value, which is obtained as 96.8368 thousands. That means the population of the city in the year 1925 is equal to 96.8368 thousands. I hope you understood this well. Thank you.